All right, students, let's move on to falling objects, aka gravity functions. The basic gravity function looks like this. H equals negative 16t squared plus vt plus c. What in the world are all of these variables? Well, h is the height in feet. All right, so here are your h values. So here would be 0 feet off the ground, 5 feet, 10 feet, 15 feet, 20 feet off the ground. There you go. Gravity functions are based off height and time. So most gravity functions, you plug in the time for t, and it'll give you the location of where it is above the ground in height. So this is going to be t for time. So some ideas or some things that you want to look for is things we're going to fall, and then we want to figure out at what time it hits the ground. So when the height is 0, that bottom line here, the x-axis is the ground. So that's probably one of the most important things we do with gravity functions. When does this thing hit the ground? V, this value right here, that's called the initial velocity, okay? The initial velocity, velocity. All right, that's basically how hard you throw the ball up in the air. And that's in feet per second. So we don't have any of that right now because this ball is just going to get dropped. Here we go. So this one's just getting dropped. So spoiler, we skip to the end. This ball is just being dropped. So where is the initial velocity? There is none. There is no initial velocity because in this case, we're just dropping the ball. We're not even throwing it up. We're just letting go of it. So there's no power behind it. Letting go of something, there's no power. The C value is the initial height. All right, that's where the ball starts falling. So that's the initial height. That's important because you need to know where something starts in order to figure out where it's going to land and all those fun things. So memorize these things, students. Most of the times the V and the C value will be given to you. The T and the H are the input and outputs that go into the equation. So we're going to have some fun with these in this chapter. We're going to mess with different starting points. We're going to mess with different velocities. But the negative 16 is always going to be negative 16. T and H can be swapped out for X and Y, okay, because this is normally X values and this is normally Y values, but for now we're going to use the proper variables, okay. Let's fill out a basic table and answer some questions about this equation. The equation H equals negative 16t squared plus 20 describes a ball being dropped from a height of 20 feet. There you go. There goes 20, 20. There is no initial velocity because it's being dropped. It's not being thrown. Fill in the table for this function and describe what each value means. Then sketch a graph. So basically we got to plug in negative 16 bracket 0 squared plus 20. I like to do the whole column first just to get them all filled out. 0.5, got to plug in a half a second. So what are these values? These are time. No time, half a second, 1 second, 1.5 seconds. And the equation will tell us what the height is. Here we go. Negative 16 times 1 squared plus 20. And then finally, negative 16, 1.5 in brackets. Don't forget the square. A lot of people forget the square. Don't be one of those people. Okay. And there it is. So I've got 4 equations. If I go to a calculator, I can calculate them pretty fast. I already have them pre-filled out on a Desmos calculator. Take a look at these bad boys. Boom. There we go. So there's negative 16, 0 squared. Negative 16.5 squared, and then the plus 20, forgot about that. Negative 16, 1 squared plus 20, negative 16, 1.5 squared plus 20. So the 4 values are 20, 16, 4, and negative 16. The nice thing about online Desmos is I filled it out, I copied and pasted 3 times, and I just changed the numbers. That's kind of nice. All right, so don't forget 20, 16, 4, and negative 16. So here we go. So my values were 20, 16, 4, and negative 16. Okay, cool. All right, so what in the world do these coordinate points mean? 0 and 20, where are you, coordinate point? Here we go. There's 0 and 20 right there. That means at 0 seconds, this ball was 20 feet off the ground, which makes sense. 0 means you haven't dropped it yet. So it's waiting at 20 feet for you to drop it. 0.5, where are you, 0.5? There you are. 0.5 seconds, it's at 16 feet. So there you go. There's 0.5 and 16. So 0.5 and 16. That means after a half second, it's fallen 4 feet. I'm not going to draw my graph yet because it's curved. It's a parabola. After 1 second, it's at 4 feet. 1 second is at 4 feet. So as you can see, holy cow, it's fallen a little bit faster. If you notice, if you drop something, it doesn't really fall very fast right away. It takes some time to build up some speed. So the second half second, the next half second, it's falling a lot faster. Look how much distance it's traveled after that second half second. And then -16, that's kind of off the grid. I don't know, -16 is all the way down under the ground. So if it's off the grid, that means you've probably already hit the ground. I said ground. Off the grid, there we go. If it's -16, it's off the grid, so it's 1.5, it's way off the map somewhere, so it's already hit the ground. So we know for a fact that between 1 and 1.5 seconds, somewhere between here and here, somewhere between 1 and 1.5 seconds, it's hit the ground. So that's what we're going to find out later on. Let me see if I can draw a nice little curve here really quick. Let's go insert a curve. There we go. So let's start right here, first point, second point, third point, and then the -16 is going to be like way off the grid, like way down there somewhere. Okay, we'll end it right there. All right, let me see if I can make my line look a little bit better. Let's make it blue, and let's add some weight to it. Let's make it a 3-point. There we go. And then it's already off the map. I would put an arrow down here. Maybe I can draw it really quick. Let's draw an arrow. What's going on? I want to draw. Can I draw, please? There we go. I want to draw. Let me draw, please. Why are you not letting me draw? Why is it doing that? Come on, man. Give me a break. I want to draw, please. Why won't it let me draw? Okay, whatever. For some reason, it's not letting me draw. I don't get what's going on here. There we go. All right, now it's back to the pencil. There we go. So the arrow would go down like that. There we go. Okay. So as you can see, it's kind of a nice slow thing, and then all of a sudden, boom, it speeds up very, very much faster. So just by our estimate here, it looks like at about 1 point, so this is 1.4, sorry, 1.5, 1.4, 1.3, 1.2, 1.1. So somewhere between 1.1 and 1.2 seconds is when it's estimated to hit the ground. So we'll do more things in the future where we can calculate this, or if you graph this in Desmos, if you go to Desmos yourself and you graph -16 x squared plus 20, you can zoom in and zoom out. You can see exactly where it hits the ground. But that's about it. That's how you fill out a basic table for a gravity function. You plug in several different intervals of time, and that'll give you where it is in height. General things don't fall too fast as soon as you drop them. They take a little more time. And then there's like a thing called like terminal velocity, where like if you fall for too long, you're going to reach a point where it's going to be very, very bad to stop right away. So, and this is why, when you jump off something very, very short, it doesn't hurt. But if you were to jump off a 20-foot building like this ball, if you drop the ball from 5 foot, it wouldn't be too bad. But if you drop the ball from 20 feet, it's booking. It's moving pretty fast at this point. So that's a calculus question. Calculus is where you can figure out the exact speed of something at an exact time and location. So you could figure out in calculus the speed that the ball is at this exact second when it hits the ground. So fun stuff, right? All right, that's gravity functions. Be good at these. Go to Desmos, graph these, have fun with these, mess with different velocities, mess with different heights. Just know that gravity will always be gravity, but how hard you throw something and where you drop it from, that's up to you to choose. All right, see you in class.